Everyone, earlier we discussed how different states of matter of a substance have different enthalpies, different relative levels of stability. So, for example, solid water is more stable than gaseous water, and that is because solid water has more hydrogen bonds, which are stabilizing. So, please note that the value for the enthalpy change to go from solid to liquid is only 6.01 kilojoules per mole for water. This breaks some small number of hydrogen bonds, but to break all the rest of the hydrogen bonds to turn liquid water into gaseous water requires 40.7 kilojoules per mole. We can see that there is heat required. You have to add heat to melt or boil water. And we'll see that here in this heating curve. This is a graph of temperature versus the amount of heat supplied to a certain amount of water, which starts at negative 10 degrees Celsius. So as we start with some just ice, this negative 10 degrees Celsius water, we add heat to that ice, and the temperature goes up. The temperature goes up until it gets to 0 degrees Celsius. And then as more heat is added, as we go to the right, we add more heat. As more heat is added, the temperature does not increase. It flatlines. We previously could add heat, and that would make the particles move more, increasing their kinetic energy, and therefore their temperature. But then, as we added heat, it did not make the particles move more per se, but instead that heat was used to break the hydrogen bonds that existed between the solid water particles. Breaking some of those hydrogen bonds turned that water from solid into liquid state. During this phase change, as there was a mixture of solid and liquid water, the temperature doesn't change. Once all of it is liquid, however, then we can add more heat, and as we add more heat, the temperature increases until it is at 100 degrees Celsius. Now at 100 degrees Celsius, you can add heat, but the temperature stops increasing again because as you add that heat, it is now being used to break yet more hydrogen bonds, turning liquid water into gaseous water. As we boil that water, as we have a phase change, having a mixture of gaseous and liquid water, the temperature stays the same. It flatlines until eventually we have all gas, and then this steam can increase in temperature further as heat is supplied to it. This has implications for you. Maybe you had your, as you were trying to boil some water for pasta, you had your heat setting on high so that the temperature would increase more quickly. But once that water is boiling, the temperature is going to stay at 100 degrees Celsius. You will boil the water more quickly, turning it from liquid into gas more quickly if you have the heat on a high setting, but the temperature is not going to change. It's going to be stuck at 100 degrees Celsius. So why not just turn that temperature down, or the heat setting down a little bit so that it remains boiling, but you're not wasting too much heat, destroying our Earth. Similarly, when there is a mixture of solid water and liquid water during that phase change, that temperature is going to be at 0 degrees Celsius. So whether you have a lot of ice or a little bit of ice, after some equilibrium is reached, that temperature will be 0 degrees Celsius. There's no point in using too much ice when you go to McDonald's or lemonade, etc., and get your drink. So we are going to be doing some calculations on how much heat is required to change a certain amount of water from one state into another and one temperature to another. So in our first question, we've got how many calories of heat would be required to turn 20 grams of water, which are at 5 degrees Celsius into those same 20 grams of water at 55 degrees Celsius. All right, so as we go to the right, some heat is being supplied. So there's some heat needed to turn that 5 degrees Celsius water into 0 degrees Celsius water. And you can use Q is equal to MS delta, or MC delta T for that. And then there's some amount of heat required just to change the state of the water from solid to liquid, i.e. Melt it, fusion, 6.01 kilojoules per mole we saw up above. And then also then you need more heat to turn that 0 degrees Celsius liquid water into 55 degrees Celsius liquid water. So we can summarize that for those 20 grams of water, we first need to see how much heat is required to increase the temperature of the solid. And then how much heat is required to melt the water, i.e. what is the heat required for that fusion, and then how much heat is required to increase the temperature of the liquid water. So that's 3 different parts. All together give us the overall amount of heat required. For just a change in temperature here and here, we can use MC delta T. We know the mass of the water is 20 grams, and the change in temperature of the water as it goes from -5 to 0 degrees Celsius is 5 degrees Celsius. But the specific heat of liquid water is 4.184 joules per gram degree Celsius, but the specific heat for solid water is quite different, 2.03 joules per gram degree Celsius. So you'll use that specific heat for solid water here. And then it will be similar for the change in temperature of the 0 degrees Celsius to 55 degrees Celsius liquid water. Mass of it times the specific heat of that liquid water times the change in temperature of the liquid water. And then finally, that heat of fusion can be equal to the number of moles times the enthalpy change for that process. The number of moles times the number of kilojoules per mole. So if we have 20 grams of water, and we can convert that into moles of water, and then we know for every 1 mole of water, we need 6.01 kilojoules to melt it, and then convert those kilojoules into joules. So we add up then the heat to change the temperature of the solid water, the heat to melt the solid water, and then the heat to change the temperature of the liquid water. And we get 1.17 times 10 to the 4 joules. But going back to the question I said out loud earlier, we're asked for how many calories are required for this process. So there are 4.184 joules per calorie, lowercase calorie. We had originally made specific heat so that, or actually we made the unit of calories be the amount of heat required to take 1 gram of water and increase it by 1 degree Celsius. That is a calorie, which is 4.184 joules. But when you look at your cereal box and you're looking at the calories listed there, those are capital C calories. There are 1,000 lowercase c calories in 1 capital C calorie. So in order to get those 20 grams and hence 20 mils of water from -5 to 55 degrees Celsius, you'll need 2.79 capital C calories. So maybe you'll need about 1 peanut burned in order to get that heat.